All right, this is the first lesson of Unit 2, and it focuses on basic probability. So the notation that we're going to use for probability is really important because probability is something that we're going to be doing all year long. So first, the capital letter P represents probability. So something you're going to see is something like this, P of A, that's how it's pronounced, and event A or event B or event C, those are all events. So if I say something like the probability of H, that's saying the probability that event H occurs. Sometimes we'll use words for this. So you could say probability of heads if you're flipping a coin. So you pronounce this probability of, and then whatever word or letters on the inside. So just some notation that we will definitely be using quite frequently. Okay, so there are several approaches to calculating probability. The one that we're going to focus on is the classical approach, and that is how many ways can something occur, or how many ways can something beneficial to us occur over how many possible things can occur. So an easy example of this would be flipping a coin. There's one way to win if you call it heads or call it tails. Matching that is the way to win out of two possible outcomes. So if you call heads, the probability of heads is 1 out of 2. One opportunity for heads out of two possible outcomes. So there's a basic formula for that, and it's just the number of ways things can occur over the number of total possible things that could occur. So getting into some basic notes on probability. First of all, really important, impossible probability is 0. You can't go lower than 0. You can't have a negative probability. Total possibility or probability, meaning there's no way this isn't going to happen, is 1. So that means all probabilities are bound between 0 and 1. All probabilities fall between 0 and 1. Be careful with rounding with probability. We like to go 3 decimal places. You can get yourself in a lot of trouble quickly by over rounding, because rounding from 0.75 to 8, probability is going to represent percentage chance of happening. So rounding from 0.75 to 0.8 is actually changing your answer by 5%, which is somewhat significant. So we like to go and round to about 3 decimal places to be as accurate as we can. So here's a couple of practice problems. If you feel comfortable enough trying these on your own, go ahead, try them, and then pause the video and fast forward to check. But I'm going to walk you through them. So we're going to try to find the probability of event D, which is going to be selecting a 7 of diamonds. So if you don't know your cards, I will do my best to explain it to you. But there are 4 suits, that being clubs, hearts, diamonds, and spades. So there's 4 suits to choose from, 13 cards per suit, and those cards are 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. And Jack, Queens, and Kings are considered face cards. So there's just an idea of what's going on. So how many total cards are there? Well, there's 52 cards in a deck. So the probability of event D being selecting a 7 of diamonds is going to be how many 7 of diamonds are there? Well, there's only 1 7 of diamonds in the entire deck, okay, out of 52 cards. So 1 out of the 52 cards is a 7 of diamonds. Now, I go to my calculator, and I'm going to type in 1 divided by 52, and I get 0.0192. So approximately 19% or so, 1.9% probability. So now, moving on to event E. Event E, and they said 3 decimal places on the rounding. I went to 4 on this one because of this first 0. I like to go to like 3 significant figures. So let's go on to event E. Probability of event E Okay, well, selecting a diamond. How many diamonds are there in the deck? 13. How many cards are there in the deck? 52. So that's going to be 0.25. Now, we always want to leave our final answers in probability as decimals. So we don't want to do the fraction. We want to get it into a decimal every time. So that was some basic probability. Now we're going to move into something really important called complementary probability. So the complement of an event, which we will use this notation right here, or this notation, which is pronounced not A. So this first one is pronounced A complement, and the second one is pronounced not A. And they actually mean the same thing. They are all things that aren't A. So if we said, what's the complement of a spade in cards? Diamonds, clubs, and hearts are the complement of a spade. Everything that isn't a spade would be the complement of a spade. So it's a simple formula. If all the probability in an event adds up to 1, and you subtract off the probability of whatever event we're talking about, we are then going to be left with the probability of not A. So if we subtract the probability of A from 1, we get the probability of all things that aren't A. So the first question here says, a typical question on the SAT requires the test taker to select one of the 5 possible choices, A, B, C, D, or E. Because only one answer is correct, if you make a random guess, your probability of being correct is 1 out of 5. Find the probability of a random guess and making a random guess and being incorrect. So the probability of incorrect is equal to 1 minus the probability of being correct. You're either correct or you're not. So all things that are not correct are incorrect. So if my probability of being incorrect, if my probability of being correct is 1 out of 5, the probability of being incorrect is 1 minus 1 out of 5. So that's going to be 4/5, which is equal to 0.8. And again, we always want to switch it to a decimal. Last question here. An insurance company determines that in every 100 claims, 4 are fraudulent. What is the probability that the next claim the company processes is fraudulent? Okay, so we have to read this question carefully here. They're saying 4 out of the 100 are fraudulent. So they're saying, what's the probability of fraudulent? Which I'm just going to call the probability of F. Well, that's going to be 4 out of 100. Just 4 of the 100 events. And I go to my calculator if necessary. Most of us can do this without a calculator, but my calculator would tell me that this probability is 0.04. And I haven't really talked about this enough yet, so let's just talk about this right now. We're going to say our final answer is probability equals 0.04. But what does this mean? This means 4% chance of fraudulent. If you were not aware, if you take your probability and multiply it by 100, you will get the percentage. So we always give our probabilities as decimals, but we want to understand them as a percentage. So this really means that 4% of claims are fraudulent. So the chances that the next one is fraudulent would be 4 out of 100, or 4%. And that's it. We just dealt with some basic probability, and now you'll get into practicing it some more.